Section 5.3 is on trigonometric function. I still think it should say functions, but whatever. General and special angles. We did this last year. We're just going to extend it today. Alright, what we have here is a unit circle. And I'm going to draw another unit circle here to help us out with something. Sorry, that should be right in the middle. Okay, so this is a unit circle. This giant thing in the middle of your page here is a unit circle. And basically what a unit circle is, it's a circle that's drawn on a coordinate plane, right? It's a coordinate plane. It's got an x-axis, it's got a y-axis. And the center of the circle is right on the vertex. And the radius of the circle is 1. So the distance from the center to any spot on the circle is 1. Now, here's something very useful about the unit circle. So I'm going to work on this little one up here. If I draw an angle in standard position, there's the initial arm, and I'll just draw the terminal arm up here. Okay? If I look, when I do that, I get an angle in here, right? There's an angle. Now, if I was to draw make the little right angle triangle, this point right here has a certain coordinates associated with it, right? An x coordinate and a y coordinate. There's something really cool about the x coordinate and the y coordinate on the unit circle. Let's figure out what it is. This point here, we don't know what it is right now, so let's just call that point xy. If that point's xy, then what's this distance from here to here? That's x. What's this distance from here to here? That's y. What's this distance from here to here? Well, it's a unit circle, and that's a radius, so it's 1. Okay, what's the value of cosine theta? Cosine is adjacent, which is x, divided by hypotenuse, which is 1. And x over 1 is just the same as x. Interesting. Sine theta is equal to opposite, which is y, divided by hypotenuse, which is 1. And y over 1 is just the same as y. This is great. Do you see that the x value, so the x value of this point is exactly the same as cosine theta, and the y value of this point is exactly the same as sine theta. So what I'm saying is every point, that's a star, every point on the unit circle has coordinates cosine theta, sine theta. It's not very intuitive. It seems a little bit hard to understand, so I'll just do another very quick example of that. Don't draw this on your beautiful circle here. If we had a standard position angle, I don't know, let's go way up here this time. If we were looking at this point right here, right? This point right here has a certain x value and y value associated with it, right? To get the x value is how far you had to move over here, that amount right there. Well, the amazing and kind of weird thing about that is whatever that amount that you moved over here, it's exactly equal to the cosine of this angle right here, cos theta. How much you moved up, the y value is exactly the same as the sine value of this angle right here, if you were to draw the triangle and everything. Okay, that's what's happening here with the unit circle. Why are we bothering with this? Because it can help us to figure out some of the angles that you need to memorize in today's lesson. So the angles specifically you need to memorize are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You need to know this cosine, sine, tan, cotan, secant, cosecant of all of those. Plus, you don't want to just know them from 0 to 90, you actually need to know them from 0 to 360. That's a lot of memorizing, but it's actually not too bad. For example, the cosine and sine of 0 degrees. Well, 0 degrees is right here, right? It's this standard position angle here, where the initial arm and terminal arm are on the same x-axis. So, what's that point right there? If this is a unit circle, that point there is 1, 0. Well, guess what? The cosine theta then is 1, and the sine theta is 0. Cosine of 0 degrees is 1, sine of 0 degrees is 0. That's fantastic. Cosine of 0 degrees is 1, sine of 0 degrees is 0. Let's go all the way up to 90 degrees. So this was for 0 degrees. Let's do 90 degrees. What's this point right here? This point is 0, 1. So that means cosine of 90 degrees is 0, sine of 90 degrees is 1. 90 degrees, 0 for cosine, 1 for sine. Okay, let's go all the way out to 180 degrees. I know it's not going to fit in our table below, but we still need to know this one. What's our cosine and sine of 180 degrees? Well, what's this point? That point is -1, so that's your cosine amount, and 0. Cosine of 180 is -1, sine of 180 is 0. And let's get 270. For 270 degrees, what's this point right here? That point is 0, -1. So cosine of 270 is 0, sine of 270 is -1. Great! Now, what about the rest of these angles? What about the 30s, the 45s, the 60s? Well, there was a way I showed you last year. I don't have it on your paper because I didn't have enough room to write it in here. But there was a way I showed you last year to generate these. So if you ever get stuck, you could do this. To get the 45-degree angles, you could draw a right angle isosceles that has 1 and 1. This side is 1, that side's 1. If that's the case, how big's this side? Well, use Pythagorean theorem. 1 squared plus 1 squared equals c squared. 1 plus 1 is 2 equals c squared, so this side is √2. How much is this angle and this angle if these two sides are 1? Well, if these sides are the same, these two angles are the same. If this is 90, then there's 90 left over. This must be 45 degrees, this must be 45 degrees. Now you can get your sine and cos. Sine 45 equals opposite 1 over hypotenuse, √2. If you want to rationalize the denominator, it would be √2/2. And cosine 45 equals adjacent 1 over hypotenuse, √2. Oh, it's the same thing, √2/2. Okay. How about this one? This is an equilateral triangle with sides 2, 2, and 2. Not 1, 1, and 1, 2, 2, and 2. If this is equilateral, how much are all the angles? 60, 60, and 60. But here's how you do this. You cut this in half. What kind of angle do you get here? 90. This was 60, but I cut it in half. It's now 30. So if I draw just the left-hand side there, I have a right triangle with a 90-degree angle, a 60-degree angle, and a 30-degree angle. The hypotenuse is 2. How big is this distance? Well, you cut it in half, so it's 1. How big is this distance? Got to use Pythagorean. You already know the hypotenuse, so it's 2 squared minus 1 squared equals a squared. 4 minus 1, so that's 3 equals a squared. This is √3. Now you can get your sine 30, and your cos 30, and your sine 60, and your cos 60. What's sine 30? Well, it's opposite over hypotenuse, 1/2. What's cos 30? Adjacent, √3 over hypotenuse, √3/2. What's sine 60? Look from this angle. Opposite, √3 over hypotenuse, √3/2. What's cos 60? Look from this one. Adjacent, 1 over hypotenuse, 1/2. Okay? So now you've got all these angles that you can plug into the table here. There is another way you could do this that I showed you last year. You could remember, I usually start with sine. You could remember at 0 degrees, sine is the same as, this is an equals, √0/2. 30 is the same as √1/2, and √1 is the same as 1/2. This one's √2/2, and you can't simplify that. This one's √3/2, and this one's √4/2, and √4 is the same as 2, so you get 2/2, which is 1. How do you get cosine? You just do them backwards. So 0, and then 1/2, √2/2, and √3/2. How do you get tan? To get tan, you remember that tan equals sine divided by cos. So once you have your sine, well, sine is 0, cos is 1, 0 divided by 1 is 0. Sine is 1/2, cos is √3/2. Got to really squish here. If you flip and multiply, you're going to get 1 over √3, which is the same as √3/3. Sorry, it's so messy. 1 over √3, which is the same as √3/3. This one's √2/2 divided by √2/2. It's the same thing, so just 1. This one's √3/2 divided by 1/2. Flip and multiply, you're going to get just √3. This one is 1 divided by 0. Can't do that. Finish tan. Now we have to get cotan. How do you get cotan? Cotan's the same as 1/tan. So just take all these values and flip them. Instead of 0/1, 1/0. Can't do that. Instead of, let's look at this one right here, the 1 over √3. Flip that. 1 over √3 flips over and comes √3/1, or just √3. Flip 1, you still get 1. Flip root 3, you get 1 over root 3, which is the same as root 3 over 3 if you rationalize the denominator. Flip 1 over 0, you get 0 over 1, or just 0. So much for cotan. How do we get secant? Secant's the same as 1 over cos. So look at your cos values and flip them. 1 flipped is still 1. Root 3 over 2 flipped is 2 over root 3, which is the same as 2 root 3 over 3. Root 2 over 2 flipped is 2 over root 2, which is the same as, if you rationalize, 2 root 2 over 2. 1 over 2 flipped is 2, and 0 flipped is 1 over 0, which you can't do. That's it for secant. Cosecant is sine flipped over. So look at your sine values and flip them over. 0 flipped is 1 over 0, can't do that. 1 over 2 flipped is 2. Root 2 over 2 flipped is 2 over root 2. Do you see that this is just the opposite of secant? So I can actually just copy. 0, 2, so this stays the same, 2 root 2 over 2. This becomes 2 root 3 over 3, and this becomes 1. Just like sine and cos are just move in the opposite direction, so do secant and cosecant move in the opposite direction. Hey, look, we're done. Well, except for this radians thing. I have to fill in the radians. Now, you could, for the radians, first of all, 0 degrees is 0 radians too. You could go through all these and do, well, I know how to get 30 degrees, switch it to radians. I just multiply by pi over 180, and then I could simplify, blah, 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 blah. But I just want to show you a way you could do it with a unit circle. What you can do is just memorize 2 of them. Remember that 30 degrees, oh, I guess I should write all these in here. 30 degrees, 45 degrees, 60 degrees. And then remember, these ones here are just a reference angle. We'll talk about reference angles in a second. If you go up 30 degrees this way, you get 150 degrees. If you go up 45 degrees here, you get 135. If you go up 60 degrees, you get 120. If you go down 30 more degrees, you get 210. We did all these last year. 225 degrees, 240 degrees, sorry, 270 degrees, 300 degrees, 315 degrees, and 330 degrees. Okay, the way you can get the radians is, okay, we know 0. Memorize this one, it's pi over 6. And memorize this one, it's pi over 4. Okay, here's what you do. This is pi over 6, or 1 pi over 6. Twice that amount, when you get to 60 degrees, wouldn't be 1 pi over 6, but 2 pi over 6, which simplifies to pi over 3. 90 degrees would be 3 of these, 3 pi over 6, which simplifies to pi over 2. 120 would be 4 pi over 6, 2 pi over 3. 150, make sure you skip that one, 150 would be 5 pi over 6. 180 would be 6 pi over 6, which is the same as pi. 210 is 7 pi over 6. 225, skip. 240, I'm going up by 30 every time, right? 240 would be 8 pi over 6, which is 4 pi over 3. 270 would be 9 pi over 6, which is 3 pi over 2. 300 is 10 pi over 6, which is 5 pi over 3. And 330 is 11 pi over 6. Can't simplify that. And if we go all the way around, 360 degrees is the same as 12 pi over 6, which is 2 pi. Okay, we haven't done them all. Now go back and look at the pi over 4, which you have to memorize. That's 1 pi over 4. If you do 90 degrees, that's 2 pi over 4, which is the same as pi over 2. Yay, we got that. Now we should go to 3 pi over 4, 4 pi over 4, which is the same as pi, 5 pi over 4, 6 pi over 4, which is the same as 3 pi over 2, and 7 pi over 4. If you do one more, you get 8 pi over 4, which is the same as 2 pi. We're finished. Okay, if you really want to finish the whole unit circle, I don't think I'm going to do it because it takes so much time. You would take the cosine and sine values that we figured out down here, and you would plug them in up here. So, for example, cosine of 30 degrees is root 3 over 2. Sine is 1/2. For 45 degrees, or pi over 4 in radians, it's root 2 over 2 for cosine. It's root 2 over 2 for sine. For 60 degrees, it's 1/2 and root 3 over 2. We've already got 90 degrees. Now, once you get to 120, it's going to be the same sort of things. Like this 60 degrees and this 120 also has a reference degree of 60 degrees. It's going to be the same values, but you need to figure out which one's positive and negative. There's 2 ways you can do that. One way is you can think of your angry Serbians take creatine, but the other way you can think of it is this. If you were going to this point up here, you would be going in the x direction a negative amount. right? So this x value, the cosine value, is negative. It's negative 1/2. But in the y value, the sine value, you're still positive. It's still root 3 over 2. Right? Is that not right? In the second quadrant, the first numbers are all negative, the second ones are all positive. And it just keeps going like that. This would be negative root 2 over 2 and root 2 over 2, etc., etc. This would be negative root 3 over 2 and 1/2. And then we get down to here. They're both going to be negative because you'd be going in the negative left and the negative down. So this has another reference angle of 30 degrees, so this would be negative root 3 over 2 and negative 1/2. In other words, for a 210 degree angle, cosine is negative root 3 over 2 and sine is negative 1/2. And you just keep going all the way around. Maybe what I'll do is I'll pause the video here and finish this off, and then I'll turn the video back on and you'll be able to see the whole completed thing if you wanted to know what it looks like. Okay, there you go. You can use that table to figure out everything for all the special angles. All we need to do is figure out write in these radians here. So it goes pi over 6, pi over 4, pi over 3, pi over 6, pi over 4, pi over 3, and 90 degrees is pi over 2. Okay, I don't know, I've tried to do the best I can. You do have to just do some flat-out memorization of this stuff. I know it's a ton of information. Ultimately, you have to learn all of this. It's all on page 230 of your workbook. If you want, you could just sit there and memorize all this. I think it's easier if you just memorize this piece of it here, and then you can use that to figure everything out kind of the way I've shown you. Okay? Okay, let's do a couple questions here with reference angles. Reference angles, you know, they're always positive. We talked about them last year. These are the bow tie angles, right? They're always acute. So in other words, they're between 0 and 90 degrees, or between 0 and pi over 2 radians. And the other thing we can say about them is they're formed with the terminal side of an angle in standard position and the x-axis. So I'll show you what I mean with that. Let's draw a coordinate plane. If we have an angle in standard position of 135, where would the terminal arm go? Which quadrant? This is 90, that's 180, so it's between there, so it'd be out this way somewhere, right? This is 135. The reference angle is always between the terminal arm and the x-axis, never with the y-axis, always the x-axis. So this is the reference angle. How much is that? Well, in the second quadrant, to get the reference angle, you go 180 minus 135, so you get 45 degrees. So really, when we say find tan 135, you only really need to find tan 45, and then worry about the sign. In this quadrant here, quadrant 2, is tan positive or negative? Well, in that quadrant, angry Serbians, only sine is positive, so tan's definitely negative. So tan 135, our final answer is going to be negative, and then whatever tan 45 is. Well, you're going to have to memorize that, or you're going to have to write out part of the unit circle or the table or whatever. I remember for myself is that at 45 degrees, sine and cos are the same. They're both root 2 over 2. And since they're the same, when I divide sine divide by cos, I just get 1. So negative 1. I don't really have, you just have to do some memorizing there. Now, I know some of you are probably saying, why are you bothering with all this drawing and everything? Why don't you just go to the table here and just look up tan 135? There it is right there. It's negative 1. The reason for that is I don't want to memorize this whole table. And so I just memorize this little red piece here, and then I use the reference angles and everything to do it. If you have an amazing memory, you can memorize the whole table, and you don't have to do what I'm doing. It's up to you. Okay, this one's quite a bit harder. Cosecant of negative 5 pi over 6. Now, I have troubles figuring out the angles when they're in radians, so I usually switch them to degrees. I imagine lots of math teachers would look down upon me for that, but that's what I do. So 5 pi over 6, I'm going to switch it to degrees, so I'm going to multiply it by 180 over pi. I can do some canceling out here. That's gone, that's gone. This becomes 30. 5 times 30 is 150 degrees, but it's negative, so I have negative 150 degrees. Okay, where is that, negative 150 degrees? Well, in standard position, negative 150, bring it over 90, and another 60, so how much has to be there? How much less than 180 is 150? 30. This reference angle right here is 30 degrees. So really what we want to figure out is what's cosecant of 30 degrees, and that'll give us the answer, but we also need to think of, is it positive or negative in this quadrant here? Well, in this quadrant, all angry Serbians take, so tan is positive, and so is the reciprocal of tan, cotan, but cosecant is definitely negative. These are positive, this is negative. So our answer is going to be negative. Now we got to figure out what cosecant 30 is. I have troubles with that. So what I usually do is I use the sine, because remember I told you I haven't memorized the whole table, I've only memorized this little bit, and that doesn't include the cosecant. So I memorize the sine 30, and I know that sine 30 is 1/2, and since cosecant is the reciprocal of that, I know that cosecant is 2. But we've figured out it's going to be -2. Okay, I know it's tricky. It is. There's just that memorization you got to do. Okay, find all the angles between 0 and 360 for which cosine theta is √3/2. Okay, first of all, which quadrants would this be in? Cosine is positive. Where's cosine positive? They're all positive here. All angry Serbians take creatine right there. So it's going to be in quadrant 1 and quadrant 4. Now all you have to do is figure out which angle, which reference angle, which angle between 0 and 90 has a cosine angle of √3/2. And I just memorized, again, I've memorized this little piece here. I know the cosine one that has √3/2 is 30 degrees. So my reference angle is going to be 30 degrees. In other words, the answer is going to be 30 degrees here and a reference angle of 30 here, which means how much is the whole angle if it's 30 degrees there? Well, that's 30 from 360 minus 30, it's 330. So my two angles are 30 degrees in the first quadrant and 330 degrees in the fourth quadrant. And last one is another one where we have radians. For exactly all x, this is angles x, between 0 and 2 pi, remember 2 pi is the same as 360 degrees, find when secant of the angle is equal to -√2. Okay, well the first thing I'd like to do is figure out which quadrants we're looking at here. So secant is negative. Secant confuses me. What's secant the reciprocal of? Cosine. So where's cosine negative? Well, all angry Serbians take... Cosine's positive here and here. Remember we said that there. So cosine must be negative here in 2 and here in 3. So we know that our angle's in 2 and 3. Now, the other thing we need to figure out then is when is it that secant x equals -√2? Well, I'm not very good with secant, so I'm going to think of the reciprocal of that. I want to know when does cosine equal 1/√2, which is the same as √2/2, right? If I rationalize the denominator. Oh, I know that one. Cosine is equal to √2/2 at 45 degrees. Does that mean one of my answers is 45 degrees? No, it doesn't, because that means I have one reference angle in this quadrant of 45 degrees, which means how much is the angle in this case? How much is that? That's 180 minus 45, which is 135 degrees. And it also means we have a 45 degree reference angle in this quadrant, and that's the reference angle. How much is the entire angle then? If we have a reference angle of 45 in that quadrant, it's 180 plus 45, which is 225 degrees. Whoops, I'm not finished, because we actually, since this question was in radians, we need to express our answer in radians. So I need to switch 135 into radians, and I need to switch 225 into radians. So I multiply them both by 180, and what happens is I can divide both of these by 45. 45 goes into this 3 times, and 45 goes into this 4 times. So I get 3 pi over 4. 45 goes into this 4 times. 45 goes into this 5 times. 5 pi over 4. There's my answers. 3 pi over 4, 5 pi over 4. Alright, lots of memorizing to do, everyone. If you like this method, this is kind of what I like actually. I just memorize this red rectangle, or you can memorize this if that helps you with the 30, 60, 45s, or you can memorize the unit circle. You got lots of options, but you got to do some memorizing. Okay, take care.